Hello, in this video, we will talk about the screening of stroke patients in Chinese medicine by machine learning. First, we will talk about the background. There are many challenges in data analytic research for stroke in TCM, traditional Chinese medicine, like different symptom descriptions, various collected clinical symptoms, and so on. Due to the complexity of stroke, there are no unified standards for differentiation and clinical classification. Therefore, it is significant to explore the pattern of stroke symptoms and carry out standardized rules. The challenge is that there are many symptoms can be recorded in the process. Select appropriate symptom subset for a certain disease to reduce the high dimension of features in the data analytic process is critical. Second, the TCM diagnostic system is non-linear, multi-dimensional, so it is difficult to truly carry out standardized studies by adopting traditional linear methods. Existing machine learning techniques perform well on binary classification, while multi-class and multi-label modeling on data analytics and natural language process is still a challenge. Third, it is found that there are many association rules between different symptoms. For example, some of them will appear together at a high frequency. Research on a single symptom or group of symptoms will lead to different results. Then we will talk about the previous work. They worked on the LDA and PCA method, but there are some shortages. The first is that this kind of method, all those patterns are assumed to be independent, which means that each two of them are uncorrelated. This is not realistic in real cases because some of them have relationships in between. The other drawback is that it cannot reflect the overlap relationship among some patterns since the symptoms are mutually exclusive after clustering. And we will talk about data sets. Data was collected from clinical records of patients from hospitals and TCM ancient books. This is an example of symptoms. And then we cleaned the data. First, since some data are in picture form, optical character recognition is applied to transform them into text form. Second, natural language processing, namely an existing model called JIBA, is used to separate the whole Chinese sentence into several words. Since the description of symptoms are ancient Chinese, some words cannot be distinguished by JIBA. For example, 四肢不行 is cut into two meaningless words, 四肢 and 不行. Therefore, a new dictionary containing TCM words is added into the existing model. Third, in order to deal with the data in a simpler and clear way, each symptom was given a number as its sequence number. The third part is methodology. Using support and confidence to represent the strength of association. Define support as the ratio of event X and event Y appearing at the same time. Define confidence as the ratio of event X appearing when event X and event Y appearing at the same time. The relationship between every two item sets is found by looking for the support which is larger or equal to the minimum support, and the confidence which is larger or equal to the minimum confidence. Notice that there is no causal relationship in the result of association rule. And this is a parallel algorithm. It applies an iterative method called by-layer search, where the k item set is used to explore k plus 1 item set. First, find the item set of frequent 1, which is noted as L1. L1 is used to find L2 item set of frequent 2, and L2 is used to find L3, and so on, until the k item sets cannot be found. Finding each Lk requires to scan over the dataset once. It is clear that the third candidate item set shrinks obviously. The first reason is that two k item sets can be linked together because of the same k minus 1 item set. Therefore, item sets like I2, I4, and I3, I5 can be omitted. Secondly, if an item set is frequent, then every item set of this item set must be frequent. For example, I1, I2, and I1, I4 can be create a new item set I1, I2, I4. However, I1, I4 is not frequent item set. Therefore, item set I1, I2, I4 can be omitted and candidate item set shrinks. Note that confident support of the two item sets in the third round is 2, which is equal to the minimum support, so it can be both collected into the frequent item set. In the next round, I1, I2, I3, and I1, I2, I5 combine together and get a new item set I1, I2, I3, I5. The new item set was sub-item set I2, I3, I5. While this is not a sequence subset, it cannot satisfy the confidence that the sub-item set of a frequent item set is also a frequent item set, so it is omitted. Therefore, in the first round, the candidate item set and the frequent item set are empty. In the end, the final result is the last frequent item set I1, I2, I3, and I1, I2, I5. Then I will show the results of our research. First, we calculated the frequency of the single symptom. This picture shows the top 10 symptoms appearing frequently in the collected cases. And as we know in TCM real cases, some symptoms have relationship between each two of them. This one shows the related symptom pairs with top 10 probabilities appearing in the collected cases. It is noticeable that some symptoms appear several times, which are also the most seen symptoms. Therefore, in order to classify them in a simpler way, we put them into 3 different categories shown in this picture. And furthermore, considering the character of TCM, yin and yang are used to classify the patterns. According to the TCM diagnosed rules, we have this picture showing the top 5 frequent symptoms of 3 patterns. And this is the picture showing the top 5 frequent symptom pairs of 3 patterns. And the last part is the evaluation. Since the diagnosed system of TCM is nonlinear, multidimensional, multi-order, and complex, it is different to standardize the study of diagnosis by the traditional linear method, and the results may not be generally accepted and adopted in clinical practice. However, data mining has the advantage that it can deal with the fuzzles and non-linear problem. In this research, NLP method is used to deal with the raw data, and a parallel algorithm is applied to find the relationship between the individuals of symptom pairs. To find the most often appeared symptoms in raw set. Frequency of each symptom is collected. According to association rules, support and confidence can be the standards showing the cohesion between each two symptoms. By applying a parallel algorithm, support and confidence are calculated until whether the relationship are close. We should notice that even though some symptom pairs have high frequency support and confidence, it does not simply mean that they have any causal relationship. And there are still some shortages. Since the data size is not big enough to test the accuracy of the used model, the result is that detailed and ideal. The shortage of apparel is that the whole dataset needs to be scanned again when the number of frequent item sets increases. It will be time-consuming if the dataset is really large. And in terms of future work, first, a new dataset is needed in the future research. A larger dataset containing standard symptoms and patterns is in need, and it will be better if more real TCM cases can be included in the study. Second, some other algorithms such as FP goals may be applied in the future work to improve the speed. That's all. Thank you.